Hello, today I'll be doing Screencast 6. I'm Peyton Thibodeau, and in this video we'll be solving this problem. So here's our given differential equation, and as you can see it's an initial value problem because we have y of 0 equals 0 and y prime of 0 equals 1. And this problem as given is the second derivative of y plus 16 times y equals u7t minus delta of t minus 13. So that is the differential equation we're looking to solve today. And we're also given initial values for this. So it's an IVP problem. So first things first, what we're going to do is we're going to take the Laplace transform. So when we take the Laplace transform, we take the Laplace of every single piece of this equation. And as you see right here, 16 times L of y, we can take constants out when we take the Laplace. And after doing that, and we do this to both sides of the equation and every piece. So after we've taken the Laplace of each form, we get the new equation in the form s squared times y of s minus s times y of 0 minus y prime of naught plus 16ys. And the right side comes out to e to the negative 7s divided by s minus e to the negative 13s. So after this, we can apply the initial conditions to our problem. And those were given where y of 0 equals 0 and y prime of 0 equals 1. So with that, we see the y0 here just becomes 0, so this just becomes s of 0. The y prime of 0 here became 1, and nothing on the right side changes. So from this point, after we've plugged in the initial values, we want to solve for y. Solve for y of s. So this first line here is after plugging in initial values. Then we start to change this in the form. So s squared y of s plus 16y of s, we can pull out s squared plus 16 and we get y of s right here. And now if we just divide both sides by s squared plus 16, we will get our equation in the form y of s equals something. So with that, y of s. We have solved for y of s, and we've gotten y of s equals e to the negative 7s divided by s times s squared plus 16 minus e to the negative 13s divided by s squared plus 16 plus 1 over s squared plus 16, reoccurring thing there. So now what do we do from here? It would make sense that taking the Laplace transform, we took the Laplace transform in our equation, we solved it for y of s. So if we took the inverse Laplace transform, well, the inverse of y of s just becomes y of t. And as we know, if we get y of t equals, that will be the solution to our initial differential equation. So if we take the inverse Laplace of everything here, we will solve our initial equation given. So first things first, this right here, 1 over s times s squared plus 16, that right there is a kind of tricky fraction to deal with. So what we'll actually end up doing is we'll split it up on a partial fraction. So we're not going to get too much into the algebra here, but 1 over 16 times 1 over s minus s divided by s squared plus 16. Using partial fractions, we get this. And as we see right here on the right side, these values are much easier to take the inverse Laplace of because they're more split up. So with that, we can, that's the last step we need to do to break our equation. From here, we can just start taking the inverse Laplace of each part. So we have 4 main parts in our equation here. We have y of s, which as we know just concludes to y of t. The inverse of e to the negative as times some function of s. We have this a few places in our equation, and that just results in function of t minus a times ua of t. We have 1 over s, and the inverse of that just becomes 1. And then finally, s over s squared plus 16 just becomes cosine of 4t. And we have that a few different places in our equation. So we just perform these inverse Laplace all across our equation, and then after we do that, we can just stitch the equation back together, and we get that in the form of y of t equals. So after doing this, we get 1 minus cosine of 4 times t minus 7 times u7 of t over 16 minus sine of 4 t minus 13 u13 of t over 4 plus sine of 4 t over 4. Now, this specific equation may seem daunting at first, but when we do split it up into those different portions and break it into smaller pieces, instead of just one big problem, it becomes a bunch of tiny problems we have to solve. And that really eliminates most of the difficulty of solving this kind of problem. So thanks for watching. This has been Screencast 6.